0, and that 0 is just holding the number place, then we would say this number had 5 significant digits. 1, 2, 3, 4, 5, stopping at the tens place. But if we said, okay, we don't think we know the population of St. Louis to the nearest plus or minus 10 people, maybe we know it to the nearest plus or minus 100 people, then we would write this as 856,800 probably, because 796 is close to 800. So we'd hold the number places, the tens and the ones place, with zeros, and we'd put an 8 here where the 7 is, and we would say, oh, that's 1, 2, 3, 4 significant digits of precision to which we know that value. I hope you're seeing what we're doing here. What we're saying here is that 6 is probably not a significant digit. We don't know if it's 6 or 7 or 0 or 2 or 3. We probably don't even know if this is a 9 in the tens place or if that should be 0. We don't know if this is between 856,800 and 856,780. We don't know that. We probably don't know the population to that precision. I'm guessing we probably don't even know to the plus or minus 100 mark. But as it's written on this sign, they're saying they know the population of St. Louis to 6 significant figures. I think that's doubtful. I don't think they probably even know it to 5 significant figures, maybe not even to 4. Look at the city of Waterloo. And I've checked, there are pictures that people have posted online before the more recent one. I assume the population of Waterloo has been increasing, because I saw a population sign that said 99,000. It had 3 zeros out in the ones, tens, and hundreds places, and it said 99,000, and it was a city of Waterloo population sign. So it seems that the city of Waterloo doesn't claim to know to plus or minus 1 digit on the ones place, or to plus or minus 1 digit on the tens place, or even to plus or minus 1 digit on the hundreds place, but they do claim they know their city's population to the nearest plus or minus 1,000 people. This sign, since those zeros are just necessary there to hold the number places so that we know that this 5 represents something in the thousands. Since that's the case, this sign implies that they know the population is 115,000 plus or minus 1,000. So that it's between 116,000 and 114,000. And that seems reasonable on a city of that size. Interesting that some cities have different standards to which they hold themselves when they're reporting their numbers. This is an interesting one. I have no idea what state or even what country Otter Tail is in, but this town, its population is 451. Now, that's not a big town. You could run around and count 451 people probably in one day. And, some people may die now and then, and a person may be born now and then, but they very well may know the population of Otter Tail to plus or minus 1 person. It may be between 450 and 452, and that's not an unreasonable level of precision when there are only 451 people. But this is, again, that's 3 significant figures in that number, and this is 3 significant figures in this number, and those are both reasonable. I think 6 significant figures on this number, 856,796, is not reasonable. And I hope I've made that case to you. Probably in a town the size of Otter Tail, they know when someone moves to town. They know when someone moves out. So they have a pretty good handle on how many people are really true citizens of that town. So let's see what we do when we have to do some calculations. We have 2 different sets of math operations for which I'm going to talk about significant figures. There are more elaborate rules, but I'm only going to talk about addition and subtraction and multiplication and division. I'm just going to talk about those 2 kinds of rules. Our simple rule for when you're doing addition or subtraction is that when you add up the numbers or subtract them, you line up the decimal points first. Then you may keep in your answer only the number of digits out to the right of the decimal place for which you have values in both numbers. We're going to do an example here, but you keep digits out to the last common number place. Here's our simple rule for multiplication and division. When you're multiplying or dividing, the factor that has the fewest occupied number places dictates how many significant figures you get to keep in your answer. In other words, you can't keep any more significant figures in your answer than there were in the factor that had the fewest occupied number places. Here's an example. Obviously, these are U.S. numbers. Calculating gas mileage. Suppose we just filled the tank of the car, and when we stop pumping, it says 18.564 gallons. Now, to figure out gas mileage, which is how many miles we go for every gallon of gas, we also need to know odometer readings. So the odometer reading right now is 180,115.8 miles. And let's say that we recorded our last odometer reading at the last fill up before we drove to use up all of these 18.564 gallons. The last fill up, our mileage reading was 179,759.4 miles. So what was our gas mileage since the last fill up? Here's how we calculate miles per gallon. We calculate how many miles we've driven, and we divide that by how many gallons of gas we've used. So, as we pointed out, to find the miles driven, you have to do subtraction, right? You have to know what's the current odometer reading and what's the previous. So here's the current odometer reading, and notice it has 7 significant figures. 1, 2, 3, 4, 5, 6, 7. The last odometer reading also had 7 significant figures, and we're going to subtract them. And the difference between them is how many miles we've driven, okay? Which is 356.4 miles. Notice that's a number that only has 4 significant figures. So we followed our simple rule for when we add and subtract, and that is line up the decimal place, do your subtraction, and you only get to keep digits out to the last number place that they have in common. Of course, this is not confusing in this case because we didn't have like a 321 out here or some other number of digits beyond the tenths place. We only get to keep digits out to the tenths place here because that's the last number place to which both numbers were occupied. So our calculation is miles driven divided by gallons of gas used. Here's our miles driven, 356.4 miles. And our gallons we got from the information given in the question. And notice the number of digits in our number of miles is 4 significant figures, and the number of significant figures in our number of gallons that we read off the pump was 5. We're going to do division when you do a fraction. That's dividing the numerator by the denominator. We're doing division, and we're going to find, we punch that in our calculator, and it gives us this number. I did this on my Microsoft calculator on the computer. That's amazing. 19.198. I'm not going to read all those digits out there. Look at all those numbers. Would you feel more comfortable like that your answer was right if you kept all of those digits? Well, in math class, they always want you to have the most exact number, and they're just dealing with numbers. They're not dealing with measurements, or many times they're not dealing with predictions. But in science, in chemistry and physics, we've taken measurements. We had a way to take a measurement of miles. We had a way to take a measurement of gallons. We're doing our calculation based on those measurements, and there were limits to how precisely we could measure those values. Are we going to say that that's our gas mileage? We got that many miles per gallon? That number has 32 significant figures. Think our cars' odometers and their fuel meters measure to the nearest 1 to the 30th place miles for every gallon driven? What we're saying is, do you think that this number is true out here to this digit? So this digit is either it's a 7 plus or minus 1. So it's somewhere between an 8 and a 6. All the way out here, 30 decimal places out on our 32 significant figure number. No way. No way can our fuel meters and our odometers measure that precisely. So we are not valid in keeping all those numbers. We only make the number less reliable by putting all those extra digits on it. So how many of these digits are significant? How many of them really have some meaning? We say, well, if you remeasured that mileage, if you remeasured the gallons, you remeasured the miles using the same meters, what number would you come up with? If you had a sister minivan, just like the minivan whose numbers we used here, that was identical, produced on the same manufacturing line, driven by the same person, the same route, would we get that amount of precision in our miles per gallon calculation? No. We remember our rule for multiplication and division is you can only keep in your answer the number of significant figures in the factor that has the fewest. And that, in this mile per gallon calculation, that was 356.4. It's got 4 number places. So we can only keep 4 number places in our answer. We can say this is, notice we're going to round to keep 4, so that 8 rounds that 9. We're going to round to get 19.2 miles per gallon, because we're limited by the precision of the measurements of the values we use to calculate. All those other digits, all of these other digits, insignificant. They are meaningless. They could flit around, bump around, go up or down. They are not significant. We cannot put any trust in them.